In this video, I'm going to introduce you to graphing a system of inequalities. So now we're going to have two lines that are going to cross and interact, and what we're going to look for is a shaded region with how they interact in terms of both of the lines. So before we've done one inequality and shading one side of the graph, and now we're going to work with two. So I just want to go through a couple steps here before we begin. First, number one, two or more linear inequalities form a system, and that system is called a system of inequalities. And number two, a solution. So your answer to your system of inequalities is going to be any point, and I'm going to write that down, point, so x comma y, where it is a solution to both of the systems. And so what we're going to look for in our graph is, for the system of linear inequalities, is the graph of all solutions, which is going to be a shaded area of the system. Only the points that lie in both half planes, meaning it's called our double shaded region, would be your solution to both systems. And so I want to show you in a picture form what that looks like. Now a reminder, the boundary line of the half plane is dashed if the inequality is less than or greater than, and it will be a solid line if you have that solid line underneath your inequality. So if we have a system together, we want to look for the shaded region that works for both, which you'll see is going to be a double shaded region. So I'm going to graph this first equation here, and I'm going to use colored pencils today just so you can kind of see the double shading a little bit easier. So I'm going to graph this first equation, negative 2x plus 2, and I'm going to start on 2 on the y-axis, which is my y-intercept point here. And I'm going to go down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. And then what I'm going to do is connect those points with, in this case, see how it says greater than? I'm going to use a dashed line to connect those points. So not quite connecting, or maybe I'll connect maybe every other pair of points. So there's my dashed line. Now for my shading, when it says greater than, my teacher told me to put this on my paper and it kind of helped me out. Here's my y-axis, which is what we solved for. And up here the numbers get greater, and here the numbers get less. They go smaller. So if I'm looking at my line, so here's my boundary line, and I have y greater, what side of the line is the greater than side? Well, it's this side where it says greater than. So I'm going to shade this side of the graph with my pink pencil. I'm going to shade lightly because what I'm going to look for in the end is a double shaded region. So I'm going to just kind of shade so that I can clearly see which side of the graph. So I'm going to shade that part of my graph. And then now what I'm going to do is graph my second function. My second function here, I'm going to start with negative 2 on the y-axis. And this type of equation, because you have no x's in here, is a horizontal line. So I know I'm going to draw a line straight across. Now it has a line underneath, so I see that solid line underneath. I know this is going to be a nice solid line. So here's my second equation. Now again, from my line, up above is greater, below is less. And if this says less than or equal to, I want to shade the side where the word less is. So I'm going to shade this region. Now, can you see the section of your graph where there is both shaded, meaning green and pink? Can you find that section here? This section where you see the double shaded happening, this region is the solution to your inequality. So if you want to actually write it down, maybe you could use like a marker. This area holds your solutions. It also will hold on this solid line solutions, not at the intersection point, because that's where a dashed and a solid meet. And remember, a dashed line, solutions are not on that line, and it will not work on this dashed line because obviously it's a dashed line, so points on a dashed line don't work. So inside the shaded region or strictly on that green boundary line would be a solution. So the question then says, let's see here, what else do I need to do? Graph the system The graph of the system is the overlap or the intersection of both planes, which we have there. And so maybe I just want to write down one more thing. These two symbols would be a dashed line. And these symbols will have a solid line. But graph like y equals mx plus b. So just kind of a reminder, you can ignore that symbol. You just want to make sure that you shade because you do have a less than or greater than symbol, and then obviously kind of like we shaded our number lines when we said like x is greater than 3 and we'd shade numbers greater than 3. That's the same idea here. Let's do one more for this video, and then I'll start a new video for the next 3 practice problems similar to these. So my first equation here, I'm going to start my graph on -1 on the y-axis, which would be this point right here. And my slope is +2, so I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. And I'm going to keep going up 2 and right 1. I notice that this is going to be a dashed line because it does not have that solid line underneath. So let me connect this with a dashed line. Now, it says y is less than. This area is going to be greater. Below the line is going to be less. And I have a less than symbol. So with my line, I want to shade the area where the less word is. So I'm going to shade this side of my graph. So I'm just going to kind of lightly shade this entire region so that when I graph my other line, it's clear where my double shading will be. And now my second line I'm going to graph at the starting point. Now, this is in the wrong order. If you don't mind, I'm going to rewrite it as -x plus 2. So it's in the form y equals mx plus b. So I'm going to start at +2 on my y-axis. And I'm going to go with my slope down 1, right 1, down 1, right 1. So I'm going to plot some points here for my ruler. Now I see a solid line underneath, so I'm going to connect this with a nice solid line. And now looking at my green line, this side will be greater than, this side will be less than, and look at our symbol, we have greater than, and so I'm going to shade this side of my graph. Can you find the double shaded region? Well, yeah, it's right here. So I'm going to just kind of emphasize, I told my students in class today, just like go ham shading that, you know, like excessively dark. Because that's your solution region. This is not a solution region, and this is not a solution region, because those don't work for both. What works for both is your solution region. So solutions would be on this green line here, or inside your shaded region, not at the intersection point because that also touches a dashed line, and also not on that dashed line because points on a dashed line won't work. I have 2 points here that we want to identify, and then we're going to say yes or no if those points are a solution to our system. And so let's check for -2. This is on a solid line and it interacts with both our shaded regions, so my answer here would be yes. And 1, 1, the intersection of a dashed line and a solid line, this is going to end up being no, because it interacts with a dashed line, and a dashed line is no. And I'll show you algebraically why. I'm going to use this first function here and plug in x and y. If 1, my y value, is less than 2 times 1, plugging in for my x value, is 1 less than 2 minus 1, or is 1 less than 1? No, 1 is not less than 1, it's equal to, and that's why the interaction of a dashed and solid line won't work, is because one of your functions will be no and the other one will be yes. But to work for the system, both answers have to be yes, the point works in order for it to work for the system. I'm going to start a new video for the 3 practice problems on the next page, so stay tuned.